So for this example, we're going to be evaluating functions. For the first question here, we want to evaluate f of 3, which means you're going to go to the f function and then substitute in the number 3. Now, when you substitute in a number for a letter, use parentheses around the number. And at first it may not seem like that big of a deal, but later on it becomes a huge deal, especially if you're subbing in a negative value. 3 squared then, 9. So when x is 3, it's basically what this is saying, the y value pops out as 9. The input is 3, the output is 9. For the next one, we go to the g function, substitute in the number -2 for x, and then again simplify. So -2 times -2 times -2, -8. Again, think about the input being -2, the output coming out as -8. For this one, you're substituting in a negative variable, but the idea is the same. You take out the x in the original problem and then substitute in the -x. When we simplify this, -x times -x is positive, and then x times x is x squared. So when they ask how does f of -x compare to f of x, well, f of x was also x squared. So f of x equals x squared, which is the same as f of -x. They are equal. So if I evaluate g of -x, again, go to the g function, take out its x value, and put in -x in its place. So a negative cubed is negative times negative times negative. You're taking -1 times itself 3 times. So it's still negative, and then x to the third gives you that result out. So how does negative, or g of -x compare to g of x? Well, g of x is equal to x cubed, and g of -x was -x cubed. So if you look at the graphs of these, and let me pull up my calculator here, if I can find it today. What you should notice, and let's clear out this, so that would do x cubed, and then -x cubed. I'm going to do a zoom 6 to get my calculator snapped on the screen. That's the first one, and then the other one actually flips around either the y-axis or the x-axis. We're just going to say it flipped around the x-axis. So it took the initial picture and then just flipped it. So what was up is now down, what was down is now up. So we say that reflects around the x-axis. You could make the argument it flipped around the y too. All right, but we're going to see later on that if you put a negative in front of the function, it flips it around the x automatically. Evaluate and simplify -2 times g of x. Well, we already know g of x is x cubed. All they want me to do is multiply that by -2. So -2 times x cubed is -2x cubed. How does that graph compare to g of x? So again, go into our calculator, and I'm going to take out, well, let's just insert a 2 here. So -2x cubed. So there's the original. One got flipped around, and actually it's a little bit skinnier. It's drawn in a little more to the y-axis. All right, so what did the negative do? Well, that was, again, a reflection or a flip around the x-axis. That's what the negative did. The 2, and we're going to talk about this a little later in the course, was a vertical stretch. So if you stretch it, it makes it a little bit skinnier. And then evaluate and simplify negative 0.5 times f of x. So I multiply negative 0.5. Notice that's not inside the function. I'm not putting it in for x. I'm just multiplying negative 0.5 times whatever f of x was. In our case, f of x was x squared. So this is negative 0.5 x squared. Right. So they want me to compare those two graphs, x squared and, let's change that power out, x squared and negative 0.5 x squared. All right, so the first one going in is going to be the x squared. The negative flipped it, and can you see how it's a little, I don't want to say fatter, but it's a little wider, right? And so what the negative did was reflect around the x-axis, and then the 0.5, we're going to call that a vertical compression. So think about it. If you vertically compress something, it kind of pushes it out. If you vertically stretch something, it kind of pulls it in or makes it skinnier. So instead of saying skinnier and, wider, we say a vertical stretch or a vertical compression.